Okay, so in the previous video, we saw the graph of kind of my favorite go-to function, which was f of x equals 2 to the power of x. We're going to explore a couple other situations and talk about what happens to the graphs in these cases. So the first one I want to graph is, it's going to look a lot like what we just did, except instead of 2 to the power of x, I'm going to do 1 over 2 to the power of x. So let's go ahead and do kind of the same thing here. We're going to create a table, x and y. I'm going to use -2, -1, 0, 1, and 2. If you plug these in, notice that in this case, this flips to 2 to the power of 2 now. So it's almost the inverse. I don't want to use that word, though, in this case, of 2 to the x. It's the reciprocal of 2 to the x. So I get 2 to the power of 2, which is 4. And then we're just going to flip that table around, and we end up with the exact same thing, just in reverse. So when you try to graph these points, -2, -1, 1, and 2, notice that I get, so it's -2 and 4, -1, 2. So in this case, the graph on the right side is approaching its asymptote rather than on the left side. So in this case, we would say the asymptote is still y equals 0, or the x-axis. But now we would say as x goes to positive infinity, y goes to 0. And in this case, we would call it exponential growth. So let's write down our two functions that we've seen. I have y equals 2 to the power of x in blue, and I have y equals 1/2 to the power of x in green. So what we can conclude from this is what's called exponential growth versus decay. Many things in nature either grow exponentially or decay exponentially. That's why this is such an important topic. So exponential growth is if b is greater than 1 in the equation that we were given in the previous video. And exponential decay, that occurs if b is less than 1 in that equation. So this is going to be pretty important for you guys to notice. When you're given an exponential equation or graph, it'll be important to be able to quickly identify what the if it's exponential growth or exponential decay. So I'm not going to spend too much more time on graphing, but I do want to give you one more example just to see what could potentially change. So let's do let's just give ourselves a function, and then we'll answer some questions about it. So let's call it h of x equal 3 to the power of x minus 9. Now let's see what we can do with it. So first of all, I'm noticing that b is greater than 1 because b is 3. So that means that this is a situation where we have exponential growth. I'm noticing that we have this minus 9, so that's going to shift our exponential graph down 9. So your first thought, even before really graphing it and being careful with the graph, is to think, well, 3 to the x probably looks something like that. It's exponential growth, and it's going to go down to down -9. So it's probably going to look something like this. Now let's see what else we can figure out about this function. First of all, let's do the y-intercepts. So I'm going to find h of 0, which will be 3 to the power of 0 minus 9. And this would give me -8. So I have that my y-intercept is 0, -8. It looks to me like this graph is actually going to hit the x-axis, so we could also find an x-intercept in this case. So in this case, we set y equal to 0, and we're trying to solve this equation here. Now we haven't really talked about how to solve exponential equations, but you might still be able to figure this out. If I add 9 to both sides, I end up with 9 equals 3 to the power of x. And if you're just kind of thinking about powers of 3, you might just recognize, well, if x is 2, then I end up with 9 equals 3 to the power of 2, or 3 squared, which is a true equation. So in this case, I could actually solve for the x-intercept. The asymptote, since the graph shifted down 9, that means that the asymptote also shifts down 9. So it used to be at y equals 0. For if we just had y equals 3 to the power of x. Since we're shifting down 9, the new asymptote is going to be y equals -9. And at this point, we could sketch a pretty reasonable graph for this function without really doing too much heavy-duty work. I know I'm going to have an asymptote at -9. I'm going to have a y-intercept at -8. My x-intercept is about there at 2. 7, 6, 5, 4. Oops, that was not drawn very well. Pardon me while I erase some of this. Let me try to draw that a little bit better. So I have x, I have y. Let's go 1, 2, 3, 4, 5, 6, 7, 8, 9. That's where I'm going to put my asymptote. I like to use kind of a dotted line for that. I have a y-intercept there. I have my x-intercept at 2. So let's go ahead now. I know the graph will look something kind of like this. And this is about the best I would expect. I don't expect you to have perfect graphs of this because that's what Desmos is for, or your graphing calculator. So if I actually went into Desmos, and I graph y equals 3, to the power of x. So I'm using this a to the power of b button next to the a squared button. And then I said -9. There's my graph. I could also plot the line y equals -9 to show that's where the asymptote is. And so now we have a nice graph of our function. However, you should be able to quickly come up with something like this. You should kind of have a sense of what every exponential graph looks like. To finish this problem off, let's talk about the domain and the range. So the domain remains all real numbers even though I shifted it down. No matter what you do with an exponential function, you could flip it, you could move it, do whatever you want with it, the domain will be all real numbers. The range, however, does change because we went down to -9. It's now going to be -9 to infinity. And that completes our work for this problem. So I started off the problem. I didn't really give you a question. I just said, let's look at a function and see what we can do with it. So what you should be able to do with it at this point, the questions you should be able to solve are things like finding intercepts. You will always have a y-intercept. You might have an x-intercept. You should be able to find the domain and range. And you should also be able to find an equation for the asymptote. So that concludes the beginning of the video. We did the first objective, which was coming up with a graph based on an equation. In the next video, we'll talk about how to find an equation from a graph.